Okay, so here's our little program that we made on Khan Academy, just because that's the only good way I know how to share programs.
Yeah.
So we call our sides 6. That's what we started with. Here's our perimeters that we calculated. The big perimeter was 4 times the square root of 3. The small perimeter was 6. These are just some dummy variables that we're going to use later.
Yeah.
Iterations tells us how many times we're going to loop through. When I set it equal to 1, we're going to do a 12-sided polygon. How many sides? 12? Okay. Because remember, each time through, the set number of sides doubles.
Oh, yeah.
So we start with 6, we go through once, we get to
12.
If we go through twice, we're going to get to
24.
Good job. Okay. And here's our for loop where we do our iterating. We use Archimedes' formula. Archimedes would probably be pretty jealous that we could do this so easily, because you saw how complicated it got even with just one step, right?
Yeah.
Okay. So then we go through, we use the formula.
Yeah.
We reset our variables to the new perimeters, double the number of sides, and then we're done. And then at the bottom, we just print it out.
Yep.
Okay, that's all we do down here. All right, so let's see. Okay, so with no iterations, we're just going to have 6 sides, and we find pi is, the low approximation was 3. The big one is about 3.46.
Yeah.
And I take the average of them. So what's right in the middle? It's to say pi is about 3.23.
Yeah.
Okay, if I go through one time, I get pi is about 3.16. And we do it just like that. Probably took Archimedes like half an hour.
Yeah.
Okay, 2 times through. Now, with 24 sides, you can imagine a 24-sided polygon starting to look a lot like a circle.
Yeah.
And I get 3.1461 is my approximation.
Well, we're pretty close to pi.
3 times through 48 sides, 3.1427. 4 times through 96 sides, 3.1418.
We could start to see the pi 3.14159.
Well, we're getting there. I think Archimedes actually calculated it out this far to 96 sides, and then he said, "Oof, I'm going to go have lunch." Here's 5 sides.
That 192.
192 sides. 3.1416. Getting close. How many times through do you want to check?
Let's go to 10 sides.
10. 10 times through, you mean?
Yeah.
6,144 sides. 3.1415927. Is that close?
Yeah.
Yeah, it's pretty amazing,
Getting
right?
closer and closer.
Now, can you imagine what a 6,144-sided polygon looks like?
Well,
Quite a lot like a circle.
Quite a lot like a circle. So
Yeah.
let's go for like, say, I don't know, 14 times through?
Okay.
98,000 sides. And I get pi is about 3.141592653.8.
whoa.
Whoa, can you imagine even trying to draw a 98,000-sided polygon?
To make each side like
I know.
That big.
It's crazy, right? So, but this is pretty neat. So this was more than 2,000 years ago.
Wow.
Archimedes figured this out. And so if Archimedes could take the time to go through this 14 times by hand on his primitive tablet,
Whoa.
that would have he could have calculated pi out as far as he wanted to. I don't know how far this goes. Can we do 16? Yeah, we can. 393,000 sides, 3.141592653.6.
We're getting there.
And we're getting pretty close. All right, do you like that?
yeah.
That's pretty neat. And it's nice how computers can help us make this approximating really easy.
Yeah.
And by the way, since Archimedes, people have figured out better ways to approximate pi.
Cool.
And one way that people use to test computer chips
Yeah.
and make sure they calculate accurately
Do
is,
they use this?
well, they do something like this. They run it through a procedure to calculate like 1 billion digits of pi,
Whoa.
and they check and make sure that they're all right, and they see how fast it can do it. So it actually is it's not just fun calculating pi.
Yeah.
It's actually being put to use in a lot of places.
Yeah.
So that's pretty neat, right?
Yeah.
All right, high five by the computer screen. Good job this morning, guys. Good job.